Welcome to Module 3. This module will focus on the materials used in exterior plastering, or stucco. We're going to look at the basics of sand, cement, and lime used in our base coats. We're going to discuss the desired properties we should be getting in our plaster mixes. We'll break down each ingredient and look at additives, and then move on to finish coats and exterior coatings. We'll look at the methods of mixing, engineered mixes, and silo delivery. The selection of materials is important, regional, and will impact the quality of your work and the life of the stucco system. There are 4 basic ingredients to make stucco: cement, lime, sand, and water. We're going to look at each one and the importance each of these materials play in the mix. Let's start with the sand, or what the code calls aggregate. This is because it makes up about 70% of your base coat mix. The importance and the quality of your sand should never be underestimated. Anything that makes up 70% volume of the mix has got to be looked at seriously. Plaster sand should be well graded. Plaster sand needs to be clean, or what we call washed plaster sand. And plaster sand should be angular. Well-graded sand refers to the sieve sizing. A sieve is a mesh with small openings, and well-graded sand goes through a series of sieves that we call gradation. Percentages of the sand must pass through or be retained by various sieve sizing. When we get to angular, the gradation or size of the sand will make more sense. Plaster sand must be washed. This process removes impurities and clays that can negatively impact sand used for stucco. Washing sand removes deleterious substances. Sand can come in bulk or in bags for smaller jobs. Regardless how you get it, it must be washed sand free of deleterious substances. Sand for good plaster should be angular. Angular is the opposite of round. Round sand is similar to using marbles. Regardless how tight you try to push them together, there'll always be voids between all the round marbles. These voids will be filled with cement. Cement shrinks, sand does not. This means round sand is subject to greater shrinkage due to more cement paste. Angular sand has less voids and fits closer together. The compaction of hard floating the brown coat will explain this further in Module 4. The sharp angles also hold and bond better than round sand. If the sand has gradation in sizes, which means variation in sizes, we call this well-graded sand. This can fill these voids even better. Washed angular, well-graded sand reduces the amount of cement paste and thus reduces shrinkage cracking. It also makes for a stronger stucco that is more resistant to the passage of water. Portland cement is what we call hydraulic. This means it hardens with water. There are 9 types of cement. The ones we are most concerned about are Type 1 and Type 2 cement, or Type 1/2 cement. This is the most common cement used and appropriately referred to as common cement. Plasticizers are then added to basic cements for plastering. A plasticizer makes the cement more workable for plastering. Plastic cement, masonry cement, and stucco cement are all made for stuccoing. Do not add lime to these cements. Lime is used to make common cement more workable. Lime also has additional complex qualities. Lime adds cohesion to plaster. This makes plaster stick better. In the US, we have Type N, or normal lime, and Type S, we call special lime. Type S lime is a hydrated lime and made for plastering. Water. Water to make stucco should be potable. This means fit to drink. Potable water will be free of harmful chemicals, salts, or other impurities that can affect stucco. Base coats. They come in a wide range of options and preferences that are often dependent on regional weather, availability, or maybe just what you're used to. While you may be given options, you do need to know some basic rules. Some products are basic cements. Remember, we called these common cements. You will need to add lime or plasticizers to make them workable. Others will have the plasticizer added in the bag and simply require you add sand and water on site. Some are fully pre-blended with washed plaster sand at the factory, and all you need to add is water. While most of these products come in bags, some come in silos, or what is also known as super sacks. It is important to know there are rules to selecting materials and ratios for mixing. Generic 3-coat stucco offers the flexibility for you to mix and make your own mix on site. This mandates you follow Table 3 in ASTM with regard to materials selected and proportions used. It is important to know the rules. The proportions are listed as parts and may be added by volume. That lime is classified as a cementitious material. This means if you make your own mix, you have to be very careful as to volume of lime added to the cement. Adding too much lime, not enough cement, or sand that is non-code compliant, you are in non-conformance to ASTM mix. If you think no one will know if your mix is too rich, has unwashed sand, or non-angular sand, you need to know about the Petrographic Analysis. This is used by material labs to take cement samples and analyze them. They can often determine if the mix was in compliance or not. You need to know the rules if you're going to mix your own batches. Generic mixing of base coats requires sand to cement ratios be in line. Many plasterers tend to make the base coat a bit too cement rich. This means not enough sand for the cement used. It is understandable as the rules are confusing. ASTM has a range of sand allowed per volume of cement. Note the range of sand varies from a minimum 2.5 to a maximum 5 parts of cement. Since the parts are by volume, we can use equal sized buckets to illustrate our mix ratio. We start with 1 part or bucket of cement and then add a minimum 2.5 buckets of sand. This is a fairly common mix used around the United States. The problem is that many plasterers forget and do not count the lime they have also added. Lime is classified as a cementitious material. This means your mix is cement rich. The total cement volume is now considered 2 and not 1 bucket of cement. To be code compliant, you will have to make a minimum 2.5 parts per 1 part cement. This means you now need 5 buckets of sand to comply with the minimum 2.5 parts of required sand. If you think no one will know your base coat is cement rich, do not forget our material scientists who can analyze cured samples to verify the stucco is cement rich. Generic mixing of plaster is risky, and why the SMA urges the use of what we call engineered mixes. These are mixes blended at the factory to meet and comply with code requirements. While they may add a slight cost to the stucco project, they tend to be less risky and ultimately of better value in the long run. In some cases, you'll be required to not only use a pre-mixed base coat, but you may also be required to use a specialty base coat. This is because the code allows for generic mixing of base coats for plaster on framed walls when they are to receive a nominal 3/4 inch thick plaster or greater. 1-coat stucco is a specifically approved base coat that allows for a thinner code-compliant base coat that can range in thickness from 3/8 inch to a 1/2 inch in thickness. This is allowed per an alternate in the building code, but must use the approved proprietary cement blend listed as a 1-coat cement base coat product. The SMA lists several approved manufacturers of 1-coat stucco on our website. And like blended cements, there are many options, including concentrates, where you can add your own sand or sanded products. Mixing base coats can be done by a variety of methods, including by hand with a hoe and wheelbarrow. Most mixing is done with mortar mixers or using hand drills for smaller projects. It is important to ensure the materials are well blended. The sand particles must be well encased in cement paste, as this is the glue that holds the plaster together. Drills must be powerful enough to blend the materials, and you should use approved mixing bits. Mortar mixers are often called paddle, plaster, or even blade mixers. These are perfect for mixing cement and sand. The blades are specifically positioned to chop and blend the sand and cement together. Always follow the manufacturer's recommendations for use and maintenance. Never remove the safety grid or put your hands into the mixing bowl while the mixer is running. It is possible the corner of the bag could be caught by the turning blades. It is important that you understand that losing a finger or hand is not worth grabbing that piece of paper from the mixer while it's turning. The barrel style mixer is not recommended for use to mix cement plaster. This style of mixer relies on aggregates such as rocks found in concrete blends to help blend the mixture. Using this style of mixer can result in lumpy or inconsistent material mixing. In the southwestern part of the United States, plaster pumps with an attached mortar mixer are very common in the stucco industry. This speeds the process of mixing and the delivery of plaster base coats. They typically require larger crew sizes and a volume of work to justify the cost and maintenance of these big machines, but they can dramatically increase production rates. Most are 4-cylinder machines capable to pump over 200 bags of cement blended with 50 tons of sand. Crew sizes typically range from 7 to 11 workers. Smaller machines are available and only require 2 and 3 workers. They're excellent for faster production rates than hand tool work, but do not require the larger volumes of work or large size crews of the big machines. Adding sand to the mixer can be done by shovel count. The recommended shovel is what is known as a number 2 or square nose shovel. This is best for a more consistent ratio of sand. A sand scoop is also possible. They are larger in size and lighter in weight than shovels because they are made of aluminum. This also means they are more susceptible to damages. The amount of sand should always follow ASTM for generic mixes and manufacturer's recommendations for concentrates or blended products. Even though sand can range in ratio from 2.5 to 5 parts per cement, some consultants may demand a more accurate measure than the shovel count. This can be done by making a 12-inch by 12-inch square box to provide a 1 cubic foot measure of sand. Once the number of shovels or scoops needed can verify to fill the box, the mixing can then be done with a shovel count. Mixing base coat plaster requires that the bowl of the mixer be clean and free of contaminants. This is best done by washing it out before starting each morning. This also has the benefit of wetting the bowl. A percentage of water should then be added to the bowl before adding any dry material. This is typically more than 60% but less than 90% of the total water required for the mix. Sand or cement can then be added to the bowl. If the batch will require more than 1 bag of cementitious material, some sand should be added prior to adding all of the cement. This should be done while the blades are turning. Again, do not put your hands into the bowl for any reason. The final amount of sand and water are then added to reach the desired consistency for plastering. Water plays an important role in achieving that consistency. Too wet, the plaster will be called soupy and it loses its cohesiveness. Not enough water and the cement plaster becomes hard to apply and can fail to key properly into the lath. In general, most plasterers seem to prefer a consistency similar to that of soft serve ice cream. However, several factors can alter that preference, and there is no correct amount of water to add or not add to be code compliant. It is strictly a job-by-job decision. The weather, method of application, and other factors all play a role in the consistency of the cement plaster base coat. The same can be said of cement finish coats. The texture may dictate the consistency as well as the substrate the finish is being applied to. Another factor in the consistency of the mix is the method of application. Hand tool application generally requires the use of a mortar or mud board. This mix may be preferred to be a little stiffer or have less water. The machine or plaster pump generally requires a looser or more wet mix. This is because the material must be able to move and pass through the hose without blockage. The hose can also absorb some of the mix water as it travels through the hose. Additives and admixtures can impart unique qualities to cement base coats. They can also ruin them. Caution should be exercised when adding any additive to a common and lime cement mix. Blended or proprietary products must get the approval from the manufacturers. A prime example is the additive known as air entraining agents. These agents can make cement more workable by adding tiny air bubbles to the mix. They can also help with freeze-thaw issues by giving trace amounts of water a place to expand. Many feel adding liquid soap does the same thing, and to a point that is true. However, there are two reasons not to use soap in your plaster. First is the manufacturers, particularly with blended products, will often already have added an air entrainer inside the blend. Having more air bubbles is a bad thing. Second, the soap is an uncontrolled air entrainer. This means it will not stop making bubbles as the material mixes. Think of dish soap and how whipping up that water just keeps the bubbles coming. This is what can happen to your plaster. Plaster base coats with excessive air bubbles will be very weak. Another additive is the accelerators or antifreeze products. They will typically accelerate the cure of the cement plaster. Some of these products are made from calcium chloride. This is a chemical known to rust metals. While fine for roads, block walls, or concrete with no metal, they can impact lath and metal trims. Thus, they are not recommended for the use of stucco on lath. There are non-chloride accelerators available. Calcium aluminite is an accelerator that has been code compliant for years. This is a brownish colored cement often called fondue. The product imparts greater strength to the cement and reduces shrinkage, making it perfect for patching. A plasterer can lath, base coat, and finish in one visit with no detrimental effect using aluminite cement. However, it must be used carefully and is best used with plaster that has already been blended and mixed. Do not put aluminite or fondue in a mixer or plaster pump. Fibers have been proven to reduce shrinkage and cracking in cement and concrete for decades. The plaster industry has known about this for centuries and once used horsehair in plaster as a common practice. Today we use alkali-resistant fibers. They should be approved for stucco, and the SMA manufacturers produce many base coats with the fibers already in the bag. You should not add extra fibers to these blends. Pumping aids. As noted before, pumping cement can require a wetter mix to allow for that slippage in the hose. Another method to gain that lubricating effect is to use a pump aid. These can make plaster flow easier through the hose. You should only use products recommended for plaster pumps. Finish coats. Stucco has the unique ability to offer the greatest flexibility and textures over all of the siding materials, from very smooth to very rough. Stucco is only limited by the imagination of the applicator, but you will need to know your materials when experimenting with various finishes. Finishes for stucco can be put into two basic categories, cement or acrylics. Each has pros and cons, and no finish material is right for all projects. Cement finish comes in a bagged powder form, while acrylics come in pails. We tend to say cement finish cures to a set and the acrylics dry to a set. There are many differences between the two finishes, and regional practices play a large role in which and why each is more popular in their region. Cement finish coats are the oldest of the stucco finishes. At one time, the term stucco referred only to the thin finish coat and not the whole assembly. Blending your own cement finish is possible but unadvised, particularly for integrally colored cement finish coats. Pre-blended products have greater workability and improved consistency of texture and color. A pre-blended cement finish has the precise mixture of sand, cement, and additives. All you need to add is potable water. The cement finish should be mixed a little stiff for the first 10 minutes, then let stand for a few minutes, and then adding a little bit of water to get the desired consistency to dump the mix. This helps break what is known as a false set. Breaking the false set in finish coat cement plaster results in greater working time and enhanced workability. The blade should then only be turned on to dump the material. The mix is typically placed on a mortar board or what we call mud board. The board is placed on a stand. Mud stands can be short or they can be tall. At one time, the hod was used to bring the cement mixed and dumped on a pre-wet mud board. This is where the term hod carrier came from. Acrylic finishes are very popular today. They come in pails and need to be blended prior to application. They may be pre-pigmented or can have color added as it is blended on the job site. Some manufacturers allow small amounts of water to be added during this blending process. It is important to mix all the acrylic thoroughly. Even all the material at the base of the bucket must be mixed. Most plasterers take the acrylic finish directly from the bucket using what is called a scoop. There are differences between acrylics and cements, or what could be called traditional finishes. While both products cure, cement is less weather sensitive and it can even cure underwater. Acrylics need air to dry, set, and cure. Both products, when set, are durable and suitable for all climates. It is common to have tenting for projects in cold regions of the country that will receive an acrylic finish coat. It is important to understand how each product sets and cures. Cement finishes cure from the inside to the outside, whereas acrylics dry or cure from the outside to the inside. This means acrylics in colder climates need warm air movement to fully set or cure. They can skim over and seem to be set, yet in reality, just under the surface, they are still soft. Removing the tenting too soon can cause a loss of bonding to the base coat. In addition, the SMA does not recommend acrylics for flat or horizontal surfaces that will be subjected to inclement weather. Both materials have sand, but cement finish coats have more body due to the cement and lime binders. This means cements also have greater texture capabilities. They also can hide imperfections in the base coat better than acrylics. The color options or choices is another difference between cement and acrylic finishes. Cement finishes can only hold so much pigment before the strength is compromised. This is why cement stucco and finish manufacturers produce color charts with limitations and generally try to stick to pastel tones. Acrylic finishes offer an unlimited array of color choices. Acrylics also tend to have superior color uniformity as compared to cement finishes. Both finishes can be painted. Cement and acrylic finishes also react differently to water with regards to water repellency. Cement finishes will absorb some moisture and then darken when wet. Some homeowners find this objectionable as they see their house darken every time it rains. Acrylics will not darken when wet. They maintain a uniform color. Both acrylic and cement finish coats are vapor permeable. This means that water that is trying to get out can do so as a gas or when it's in its vapor state. The moisture vapor will pass through what we call vapor permeable materials. While the 100% acrylic finish does repel bulk rainwater, it does allow water to escape as a vapor. This is an important and desired characteristic. We should accept that smaller incidental amounts of moisture will find its way into the stucco wall at some point. We must allow it to escape. Both cement and acrylic finishes allow this moisture to escape. When water cannot escape through the finish coat, it will tend to blister or bubble the finish off of the base coat. The same can be said of paint coatings. Painting cement with an elastomeric coating can result in blisters when the moisture tries to escape through that non-vaporable coating. This is why the SMA recommends vapor permeable coatings for all cement base coats. Sand finish is easily done with both cement and acrylic finishes. This is probably the most popular finish across the United States. Both use sands to determine the look of the texture. Acrylics tend to use the terms fine, medium, and coarse. This is the difference of the sand size particles in the material. Unlike the base coat, gradation or certain sieve sizing requirements are not needed for finish coats. The same is true for cement finishes, but they tend to specify the actual size of the sand. The most popular uses are 1620 and 2030 sand blends for cement finishes. Each material also has specialty blends for unique textures. Such examples are Mission or Santa Barbara finish used in cements, or the Amerstone finish used in acrylics. Each manufacturer will have unique and special blends. Good plasterers should keep an open mind to all new products and strive to learn to use them to improve projects, enhance value, and to help grow the industry. Plasterers will often be told the finish coat is going to be painted, so color is not really important. They, for whatever reason, then opt to use a base or plain white finish, and that's certainly acceptable. However, it should be noted that finish coats can take time to fully cure and set. This means the sand particles are vulnerable to being broken off until that full cure is taken set. For cement finishes, this can be up to several weeks. This is also the time the walls are being subjected to more abuse from cleanup crews and other trade damage. We have noticed that when these particles break off, they leave white spots. This is particularly noticeable on darker painted walls. It is a good idea to still use a pigment that closely replicates the painted surface to prevent callbacks. This concludes Module 2, Base Coat and Finish Materials. Key points to remember are: generic mixes must follow ASTM standards for ratios and product use. Sands are critical and must be graded and washed. Thinner base coats are allowed by the building code, but you must use the approved products. Lime is considered a cement material. Acrylic and cement finishes are both vapor permeable. You should avoid cement-rich base coats. You should be open-minded to new ideas and new products. In Module 4, we will cover the application of stucco.